సో ఈరోజు మనం వీడియోలో చూసేది ఏంటంటే కైనమాటిక్ ఈక్వేషన్స్ డెరివేషన్స్ బై ది గ్రాఫికల్ మెథడ్. ఈ గ్రాఫికల్ మెథడ్ క్యాల్కులస్ మెథడ్ కంటే ఎందుకు ఈజీ అంటే ఇక్కడ డెఫినేషన్స్ గుర్తుపెట్టుకోవాల్సిన అవసరం లేదు. ఈ గ్రాఫ్ మీద ఉన్న వాల్యూస్లో లెంత్ అండ్ ఏరియా ఈ రెండింటిని క్యాల్కులేషన్ చేయగలిగితే కైనమాటిక్ 3 ఈక్వేషన్స్ని మనం డెరివేషన్ చేయొచ్చు. సో అది ఎలాగో ఇప్పుడు చూద్దాం. అలా చేసే ముందు ఫస్ట్ గ్రాఫ్లో ఏమేమి వాల్యూస్ మీరు గుర్తుపెట్టుకోవాలో దాని గురించి కొద్దిగా మాట్లాడదాం. సో వాట్ ఈస్ గోయింగ్ టు బి గివ్ దిస్ స్లోప్? దిస్ స్లోప్ theta, tan theta is going to give what? And just a straight inclined line is going to give us constant slope. Wherever you take the slope, the theta is going to be constant. Means if theta is slope, we are saying means constant acceleration. Tan theta is equals to constant, or acceleration is equals to constant. So what is that tan theta value? Opposite side by adjacent side for this triangle. So what is the opposite side? This is the BC. And what is the adjacent? AC. So A equals to acceleration equals to. So how we know that tan theta is going to give us the acceleration? So if you check with their units, BC value is going to give us what? V minus U. Mean what is going to be the change in velocity units? Meter per second. What is the AC value? AC value is again second. That is going to give us meters per second square. So మీటర్స్ పర్ సెకండ్ స్క్వేర్ ఉన్న ఫిజికల్ క్వాంటిటీ ఏంటి కైనమాటిక్స్లో అని చూస్తే మనకు చాలా క్లియర్గా అర్థమవుతుంది, అది యాక్సలరేషన్ అని. సో టీటా ఈజ్ గోయింగ్ టు గివ్ అస్ వాట్? acceleration on VT graph, because we have taken velocity time graph for deriving the kinematic equations. Now this is one we got. So what is going to be the area? Number 1 slope calculate చేస్తే ఏమొస్తుంది అర్థమైంది. నెంబర్ 2 ఏరియా క్యాలిక్యులేట్ చేస్తే ఏమొస్తుంది? సో x మీద ఉన్న క్వాంటిటీ టైం, y మీద ఉన్న క్వాంటిటీ వెలాసిటీ. సో ఇఫ్ యూ మల్టిప్లై వెలాసిటీ ఇంటూ టైం, వాట్ యు ఆర్ గోయింగ్ టు గెట్? Definitely it is going to get displacement. So what is going to be the units of displacement? It is a meter. So that again you can recheck here, meter per second into second. Seconds gets cancelled, you are going to get meter. So that way you can conclude area is going to give us what? Displacement or distance. It is a one dimensional body, we are one dimensional motion we are imagining. That's why we can say that is a displacement. Now let's come to our thing. So axis ikkada axis x axis y axis edaithe తీసుకున్నామో దాని origin 0, so or O. So here the graph value starts with a b, and under the ab graph, so what is the area we have to calculate? So when it comes, just you have to be very careful how we are going to calculate that. So now let's come to, so what is the first equation, kinematic equation to calculate? We can do very simple thing. What is that simple thing to do? Is calculate the length BD. You have to calculate length BD. If you calculate, you are going to get the first kinematic equation. What is that length BD? So look at the graph carefully. BD. So that BD total is going to give us what? Equals to V. So that BD equals to what? You can write in 2 steps, BC plus CD. Can we write BC plus CD? So now that is BC plus CD. And one more term you can understand, AO equals to CD also you can understand. This one equals to this one. So these కాబట్టి ఇక్కడ మనం ఏం తీసుకోవచ్చు? AO equals to CD equals to this value is nothing but initial velocity U. And now that value OD equals to what? OD equals to T. So all the values, just whatever the graph representing, that value should be remembered. And otherwise when for our derivation purpose, whenever we look at the graph, you have to remember that, recognize them. Let us see that. BC equals to, from the tan, BC equals what you can write? Into AC. AC is nothing but what? AC equals to T. Then now you can write BC. BC value equals to 80 plus CD value equals to CD. That CD value equals what? U. So what is the BD value? V. Now what you got? V equals to U plus AT. Okay, we got the first kinematic equation. That's all. So just now I told na, length calculate cheyadam vaste equation derivation vachesindi. That is from the graph directly. Now second equation calculation. So you can simply find the total area. The area, you are going to calculate area OABD. So you are going to calculate area OABD. So just if you want total area, can you calculate that as one triangle area and another one rectangle area, right? So these two areas, if you add, you are going to get total area OABD. That's it. So now that's why I am writing it as sum of triangle area. What is that? ABC plus and rectangle area. What is that rectangle? OACD. So what is the triangle area? Half into base into height. So that area gives what? Already just now we know that. So that value, yes, we are indicating it, the displacement. And triangle ABC, triangle area half into base into height. What is the base? AC. Half into base into height. Height is going to be for that triangle is nothing but V minus U. Plus what is that? Rectangle area, length into breadth. So what is going to be the length equal value? Here it is T, you are going to take, another one is U. Now V minus U equals to what here? From the tan theta you can write it. BC is nothing but A equals to V minus U by T from the BC. BC value V minus U, no, AC value T, that's why this is. So instead of V minus U, what can I write? I can write as a AT. So that value if I take it, half into AC value equals to, already we know, that is time. This is going to be 80 plus U into T. Now what is going to be this? UT plus half into AT square. Okay, we got the second kinematic equation what we need. S equals to UT plus half AT square. Next, third one is you are going to get by using calculating the area of trapezium. So if you calculate the area of trapezium, simply you are going to get the third kinematic equation. So what is that? Let us see. The trapezium is what we are going to take, O, A, B and D. OA, BD. So in a trapezium term you are going to take it. What is that? This way it is having like this. Okay. So two parallel sides O, A, B, D. Average of that into height. So this is going to be taken as a height. This is T. The parallel values are going to be U and the total value V. So what is going to be the average of that? V plus U by 2. This is the average of two parallel sides into what is another? Height is T. T equals to what you can write from this? So by using this you can write T equals to V minus U by A. Now if you substitute that value here, V plus U by 2 into V minus U by v minus u by a. So that equals to like a plus b into a minus b, a square minus b square. And what is the value already we have here? It is the s value. So 2a, if you cross multiply this side, 2as equals to v square minus u square. So finally what we got? We got the third kinematic equation, that is v square minus u square equals to 2as. So in this way we can easily calculate the kinematic equations from the graphical method. Thank you. So but one more question, why we have taken velocity time graph instead of position time and acceleration time graph for calculating the kinematic equation? Just once you think, and if you know any reason, you can comment in the comment section. Thank you.